Okay, in this question, we have four parts, and in all of them, we need to compute the derivative, f prime, of the function. So let's start with a. F of x is this function, so it's of the form something to the power 5. This is what we noticed at the beginning. So this whole thing, you can call it heart. So f becomes heart to the power 5, and we know the derivative of such thing is you bring the 5 down, subtract 1 from the power, and the chain rule tells you that you still have to multiply by the derivative of this heart. So this will become 5 times x to the 4 minus 1 over x to the 4 plus 1 to the power 4 times now the derivative of heart. We apply the quotient rule. So it's the derivative of the first times the second minus, we need more space probably. So let's do it with more space like this, minus something times something over the denominator squared. Okay, so over the denominator here is x to the 4 plus 1 squared. And now we start putting things. So here we have, this is the numerator and this is the denominator. So the derivative of x to the 4 minus 1 is 4x cubed times the denominator is x to the 4 plus 1 minus the numerator is x to the 4 minus 1 and the derivative of the denominator is 4x cubed. And so this will become 5. Let's keep calling it heart to the 4 until the end, then I will write what it is, just to save space. And now here this is x to the 4 plus 1 squared, and the above, let's try to simplify it, this part. So this will be equal to, this will multiply the 2, so you'll get 4x to the 7 plus 4x cubed, and from here you'll get minus, and then 4x cubed times x to the 4 is 4x to the 7, and then minus minus is plus, the minus minus is plus, and then 4x cubed. So you'll get 4x to the 7 minus 4x to the 7 cancel, and 4x cubed plus 4x cubed is 8x cubed. And so you see how nice it is. Now it's becoming smaller. So it's equal, now when you multiply 5 times 8, this is where you will get a 40. So it will be 40x cubed. This is the x cubed from here, and 8 and 5 gave us 40. And then heart to the 4, so just write heart as it is. X to the 4 minus 1 over x to the 4 plus 1, all of it to the power 4 times, what's left is this one squared. So 1 over x to the 4 plus 1 squared. Notice that you can still do one more step, and because here you have x to the 4 plus 1 squared, you see, and here x to the 4 plus 1 to the power 4, you can multiply them and get power 6. And so you get it like this, 40x cubed times, and then the numerator will be x to the 4 minus 1 to the 4, but the denominator is x to the 4 plus 1 to the 6. You can do it like this, or just keep it as the way it's written like this, to keep heart to the power 4 together. So either you write it like this or that. If it's a multiple choice question, maybe one option will be this and one option will be this as a choice. So you choose whichever one is given, but you know that this is the way to do it. So that is for A. Let's do B. So in part B, there are two ways to do it. Either you first FOIL, multiply this and FOIL it, and then take the derivative, or apply the product rule. Think of this as heart and this as diamond, and then apply the product rule. Heart prime times diamond plus heart times diamond prime. That would be the derivative by the product rule. But what I want to do is I want to first FOIL it, because this will make it much easier than applying a rule. I mean, the product rule is a rule that requires some concentration, but if you first FOIL, look what you'll get. You'll get 2 By the way, radical x is the same as x to the power 1/2. Remember this. So when you FOIL it, 2x cubed times radical x will be 2x to the 3 plus half will be 7/2. Okay, then plus 2 times 2 is 4x cubed. Then minus 1 times radical x is minus radical x, which is x to the half. And then minus 1 times plus 2 is minus 2. So in this way, you wrote it in a much easier way. Now it's a power function, complete power function that you can take its derivative easily. So the derivative, just bring the powers down. So 2 times 7/2, that will be 7. X to the, subtract 1 from 7/2, it's like 2/2 is 1. And so 7/2 minus 2/2 is 5/2 plus. Now 3 comes down, multiplies the 4, you get 12x squared. Minus the half comes down, and then you subtract 1 from half, you get negative half, minus the derivative of 2 is 0. And now just simplify what it looks like. So this is 7x to the 5/2 plus 12x squared minus 1/2 radical x. So you just put x to the power negative half is 1 radical x. Just it looks nicer this way. So this here is our final answer for the derivative. And for this one, let's check that our answer is correct. So I'm going to get the calculator now and put this function in it. So let's see here. So we want the derivative of, and and then I put this one here. So 2x to the power 7/2, and then plus 4x cubed, 4x to the power 3, minus x to the half, which is radical x. I can say radical x. And lastly, minus 2. This was my function, and I want its derivative equal. So here you see, let's check them one by one. 7 times x to the 5/2. This is, by the way, this you can write it also as 7 times the square root of x to the 5. You can write it like this. Plus, and notice they have 12x squared. Second one in the calculator. And then minus, they just wrote this as the half up and down is radical x. This is the same exact thing as it's written like this. You can either put the 2 up or down. At the end, it's in the denominator, the 2. Here, either you put like this or in the numerator as a denominator. That would be in the regular denominator. Okay, so we checked and this is correct. So let's go to the third question. And in this one, I want you to remember this. I put a star here. Any question that has ln, whether it's integrate or differentiate or do whatever, just make sure that what you have within the ln is as simple as possible. So use the properties of ln to simplify it. So that's what we will do now. This is equal f of x. I still don't want to take the derivative yet. Don't start. First simplify. This is ln, and this is like 2x plus 1 to what power? Power 3, but then the fifth root here, this is the same, equivalent to power 1/5 as a power. And then you have another power 3, so you multiply them, you get 3/5. Perfect. So this way you wrote it as a fractional power, and now use the property of logarithm that whenever it sees a power, it brings it down, as long as the power is within the logarithm. Like if you have ln x squared, like this is, yes, correct, it's 2 ln of x. But ln x, if you have it square like this, the square, this is not the same as 2 ln x, because the 2 here is for the entire thing. It's for the ln is raised to the power 2. This, it cannot control the power that it's raised to, but if the power appears inside the logarithm, then you can take it out. It's just a common mistake. I just want to remind you of it, that don't make this mistake. Only you bring the power down when it is within the log. There are parentheses and the power is within the parentheses inside the log, then you can bring it down. So when it comes down, it will be 3 over 5 times ln, and look now, it will be just 2x plus 1. Very simple now. So therefore, the derivative f prime of x equals 3 over 5 stays, and then the derivative of logarithm. Remember, it's the easiest one. It's just the denominator is the same as what you have in the logarithm, and the numerator is the derivative of it. The derivative of 2x plus 1 is 2. Just this. So if you have ln of anything, let's call it heart, and you want to take the derivative, it's always going to be a very easy rule. It's heart prime over heart. Okay, remember this always. The derivative of logarithm is one of the most attractive derivatives and simplest. It's just the derivative of the inside over the inside. So that's why here you have the derivative of the inside is 2 over the inside is 2x plus 1. And now if you multiply this, 2 times 3, you get 6 over 5 divided by 2x plus 1. This is the derivative. See how simple it is and attractive the way it looks. So f prime of x is this. And we can check our answer. So let's get the calculator up and see what would it give us when we put the derivative of here. Let's write it as ln. So we want ln of a big thing. So I'll put it here, 2x plus 1. All of it raised to the power, and now we put 3 over 5. You know, this way we ask that for the derivative and we see 6 over 5 over 2x plus 1. Notice it's exactly, so we put a happy face, exactly what the calculator gave us. Good. So this is correct. And now the last part of this question, the derivative of this one. So notice here, f of x is equal, this part, 1 over 6 pi squared. Do not do the derivative like bring the 2 down, because why? This has no x's. So no x's, which means it's a constant, which means the derivative of a constant is 0. So this will give me 0 derivative. This one here, yes, it has an x, yes. So this will have something. But this here is a constant, so the derivative is 0. Let me erase and do it again. So f of x, let's rewrite it. I'm going to write it again. This is pi squared over 6, which is a constant, plus, look at this one. It's 3 to the power 2 minus 3x. This here is an exponential function. Remember, an exponential function is the a raised to a power of x, like something like a to the 2x plus 2. This is an exponential function, as long as a number is the base. So, and x is in the exponent. Here you see a number is the base, 3, and in the exponent you have the x. So it is an exponential function. Perfect. So now, what is the derivative then? Therefore, f prime of x is, for a constant, the derivative is 0. For an exponential, it's the same. Always you copy paste it as it is before you continue. Okay, first copy paste it, times, and now the derivative of the exponent with respect to x, the derivative of this is negative 3, times, because you have the base 3, you need to multiply by its ln. So you put ln 3. When it's e and you put ln e, it's 1. It doesn't show. But when it's any number other than e, you have to put ln of the number. And of course, you have the formula sheet with you. You'll see it there. You shouldn't make a mistake with this. So therefore, f prime of x, finally, we will write it here. It's equal minus 3 ln 3 times, so this is the constant, times 3 to the power 2 minus 3x. Okay, so we claim that this is the answer, and let's check it. So if we get the same as what we have here, we know that our answer is correct, and if it's a multiple choice, we will make the choice that looks like this. So you need to always be careful with when you have 4 choices. Make sure that you choose really the right one. Because sometimes they can look similar, especially when they have logarithms and powers like this. So we want to do d by dx of, now pi squared over 6. We don't have to do it, but because it's a constant, but I want to put it so you see that you can get pi. So here, shift pi squared over 6, and then we put plus 3 to the power, and the power is 2 minus 3x. 2 minus 3x. So it is this one, yeah. Derivative equals ln 3, I have it, yeah, and then times minus 3. What they did is, because this is a 3, it's like a 3 to the power 1. So what they did here is they took this and said that these two together, 3 to the power 1 times 3 to another power, 2 minus 3x, because it's the same base, we can add the powers. 1 plus 2 minus 3x. I added the powers, and so 1 plus 2 is 3 minus 3x. Okay, so you can even simplify this further and say it's equal minus ln 3, and then the 3 you add the power 1 to 2 minus 3x to get 3 minus 3x. Yeah, this is simpler than the way I wrote it initially. Okay, so let's check now. As it is here, it's the same, of course, as the answer, with a happy face. That sometimes, you need to do one extra step, especially if it's a multiple choice question and you need to check your answer. Like, let's say that you wrote this when you answered, but in the choices, this is, of course, the right one. And you just need to remember that if I multiply this 3 by this 3 to this power, then I add the powers. And the power of 3 by itself, if it's like this, is like power 1. And the other one had power 2 minus 3x. So this plus this, you add the powers. So you'll get 3 to the 1 plus 2 minus 3x, which is 3 to the 3 minus 3x, as I did before. Just for you to see that sometimes you might need to do one extra step to get the choice that is in the choices. Not to say that the choice doesn't exist. Okay, so that will be it for this question, and I will stop here.